Ready to learn how to turn that into this? Well, let's get stuck in. Hello and welcome to another episode of James Dean Designs. Now, when I first got into CNC, I used to set myself little challenges as a way to improve my skills, and one of those was making this, a mini turner's cube out of a little piece of oak. Now, I thought a few years later, a bit more experience, let's step it up a level and make one out of solid aluminium. And that's exactly what I'm going to be showing you today, how to turn this solid block of aluminium into one of these beautiful turner's cubes. So let's take a look at the setup and get stuck in. So this is the block of aluminium we're going to be working with today. It's approximately 2 inches wide, as we can see against the ruler there, but there are a few things we need to do before we even start machining any of those holes. The first is, do not make any assumptions. Do not assume that all sides on this block are perfectly parallel, and also do not assume that this is a perfect cube. It's actually not. Some measurements are about 0.5 millimeter out. So the second step we need to do really is to counteract those things that we just mentioned in order to get this to be a perfect cube. So we're going to begin by surfacing every side of this cube, just taking a skim off about 0.2 millimeters, just to guarantee then that all faces are perfectly flat and also parallel with each other. Then after we've done that, we will take the measurements of what is remaining and make it into a perfect cube. So let's say one measurement is about 0.3 millimeters longer than the other, then we will take 0.3 millimeters off that side in order to get it perfect. Now, the more accurate you can be in this process, the better results you will get at the end once we start machining all those inner parts out. So let's get this set up and start getting it faced. Now, in terms of holding your block of aluminium, there are obviously multiple clamping methods you can use to hold this in place. Today I am using this device, which is called a low profile vise. It has multiple holes where it can be held down to the bed itself, as well as adjustable jaws that you can obviously adjust depending on the material that you are holding. When you are working with blocks of metal, these are brilliant. They're about $50, but it is well worth the investment. And this is what I'm going to be using today, as I say, because ultimately it just makes life much easier when we are machining blocks of metal. So I'm going to get this set up and locked in place now. So the aluminium is held in place nice and secure. The bit is set to the 0 at the dead center of the material. We achieved this by doing 2 diagonals from corner to corner, and it gave us the dead center in order to begin the job. Now we are about to take 0.2 millimeters off the top of this and ultimately surface the top of the cube. In terms of creating a file for this, it is relatively simple, but obviously will vary between CNC software. So what you'll want to do is draw a square slightly bigger than the area you're going to surface. So in this scenario, this is a 2-inch square. We drew a square that was 2¼ inches. Now the reason for this, it just guarantees that it's going to catch every edge and not leave any corners. So it will go slightly bigger than the area, but it will mean it machines the entire top surface of this cube. Now, in terms of rotating this round, there is a certain order we will do it in, and I'll talk you through it as we do it. But ultimately, the first thing we need to do is get one surface completed and faced. So with the top now surface, we're going to flip this 180 degrees so the top becomes the bottom, and I'm also going to mark on the vise where it's sitting, just to make life easier in terms of repetition and the cuts going forward. So let's continue and get the second face done. So we now have 2 sides that have been faced, what is the top and the bottom. We're going to flip this around so those 2 faces sit within the sides of the jaw. And with that done and the 0 reset, we'll go again. So now we have 3 sides done, the left, the right and the top. So we're going to flip this over 180 degrees. So those sides stay within the vise and the bottom one goes at the bottom of the vise. And the same, let's go again and get the 4th side done. So there's only 2 sides that have not been cut now, the front and the back. So we're going to flip it one way, do that surface, then 180 degrees over the other way to get the other one done. So there we have it, all 6 sides have now been faced. The next step is to take this out, check some initial measurements and see how far off this is being out from a perfect cube, and if necessary then just take a little bit off 3 of the sides to make sure this is as close to perfect as we can possibly get it. I'll show you how to do that now. So this next section does require a little bit of math. Don't be too put off by it, but ultimately the more accurate we can get this, the better the results are going to be at the end. So what I've done is marked the cube up with 1, 2, 3, 4, 5, 6 all the way around. It doesn't matter what side you mark them, as long as you remember the pairs. So in this scenario, 1 on the front, 3 on the back, that is a pair. 4 on this side, 2 on that side, that is another pair, and ultimately 5 and 6 become the third pair. So what we're going to do now is take the measurement for the 2 and 4 pair. So we're going to bring the calipers in and we're going to take the measurement for 2 and 4. That is coming in at about 50.81. For ease for this video, we're going to call that 50.8. So on that face, we're going to put 50.8. Excuse the scruffy writing, but it's just as a reference so I know what it is. Then we're going to spin that one round and we're going to do 1 and 3 now. So we're going to bring the calipers back in and that is coming in at 50.19. So again, for ease for the video, we will call that 50.2. So if I mark that up and go 50.2. Now what we know is between those 2 sides there is a 0.6mm difference. If I flip this over now and do the final set, the 6 and the 5, we have approximately 50.7mm. So again, mark that one up. So after we have done all the 3 measurements, now we have 50.2, 50.7 and 50.8. So we know that the 2 sides are bigger than one side. So we want to try and get the other sides down to 50.2. So on the 50.7 side, we will need to machine off 0.5mm off this face. On the 50.8 side, we will need to machine 0.6mm off this face, and that should ultimately get them both down to the same then as the remaining pair. Now what I will say at this point, in theory these sides should all be parallel, but if I show you something and bring this in, at this point we're measuring at the back of the cube, that is coming at 50.59. Now if I bring it to the front of the cube, that is 50.76. So what we can see is, although these should be parallel with each other, there is some discrepancy. So take multiple measurements and ultimately work off whatever is the largest of the measurements when you are doing these checks and your calculations. And then, as I say, factor that in as part of your measurements. So as a quick alternative, if you don't want to do the math for every side, you could just set a measurement that you want to achieve with every pair. So the smallest measurement that we had was 50.2. So we could actually say, well, let's make every set of pairs just 50mm in width. And that way we would take 0.2 off one side, 0.8 off another side, and what was it, 0.6, 0.7 off the final side. And that in theory should all bring them down then to the same width. Now after explaining all that, there is a second method to achieve what we're after, which is ultimately to get a set depth on this material. And that is by setting the 0 from the base of the vise as opposed to the top of the material. Now the reason I've left this until last is because if you are new to CNC, this may be a little bit confusing and ultimately maybe a bit of information overload. So don't worry too much if you don't understand this method. But I will explain it just because this is one of the scenarios where it is actually useful. Now 99% of the time you will always set your Z0 from the top of the material and work down into negative coordinates. But in this scenario, because we're trying to achieve a set depth of multiple sides on this cube, what we can actually do is set the 0 to the base of the material and work upwards through into positive coordinates. So what we were essentially going to do is tell the machine that this is the base that we want to start on, this little ledge, and the material is 51mm thick, but ultimately we want to machine it down to 50mm thick. So when we rotate this cube, it's always going to take the 0 as the base of this vise, machine down to 50mm, flip it over, start again, machine down to 50mm, flip it over, machine down again. Now, as I say, this is a method that you will rarely use. 99% of the time you always start from the top, but it is one positive example of how we can use this base Z0 to achieve what we're after in this scenario. And it's also the first time I have ever used this method. So I'm going to see how it works and the results that we get from it. One final tip I should also mention is that after you've done all the machining on the side, you may notice some of the edges have a little bit of a burr on them. So before you start bringing your calipers in to take the measurements, make sure you get rid of those little burrs, as it may affect the actual measurements that you're taking. So with everything in place, I'll try and explain what I just said about setting it from the base. So normally this level here would be your 0, so the bit at the moment would be 5mm above the height of the 0. But what we can actually see on the screen, it is shown as 55mm. That's because I set the 0 as this little ledge here. I lowered the bit down and set it off this little ledge, and I've told the software that as well. Now this, as I say, is just one way to guarantee of getting perfect thickness of material, as opposed to keep setting it from the Z height, because ultimately every time we rotated that cube round, it is a slightly different measurement, whereas this method, we're setting it consistently off this ledge in order to achieve a guaranteed thickness every time we rotate the cube. So a bit like we did earlier, we're now going to flip this over and machine one of the other sides, as I say, to get that pair down to 50mm as well, and then we'll do it a third time, and all being well, after we have machined all 3 pairs of sides, it should then give us the 50mm cube that we're after. Now, I have no issues with pointing out my mistakes on videos, and what we can clearly see here is it machined probably just over the first 3/4, and then it drops off because obviously something wasn't quite square in what I've done. So what I'm going to do now is reset this file to take a little bit more off. Instead of bringing it down to 50mm, it's probably going to have to come down to 49mm in order to get this last little bit off and ultimately try and keep this as square as possible. So I went back and did the first side that we cut down and took this back down to 49mm now to match the other 2 sides. And just as a reminder, when doing this phase of it, you only need to do 3 sides in order to get this to the cube shape that we are after. Now, in terms of accuracy, this is probably accurate to within about 1/10 of a millimetre, which I am happy with in this instance. Obviously, the more accurate you can be, the better it is. But now at this phase, we can jump over to the PC and do the calculations for working out the holes that we need to machine into this. So the first thing you're going to want to do is head to Google and search for GWizard and go to the first result for CNC Cookbook. Now, GWizard is a piece of software designed by CNC Cookbook that ultimately is quite useful for CNC people. Now, as you can see up here, it is chargeable, but you do get 30 free days, which is obviously ideal for a quick project like we are trying to do today. Now, scroll down and you will see the various buttons to start the trial and to download the software. So go ahead, get everything downloaded and installed. Now, when you load it up, it will look something like this. Now, as I just mentioned, it is ideal for CNC people. There are lots of different features in here, such as feeds and speed calculators. Now, I will point out this is designed for larger machines, not smaller desktop machines, so the feeds and speeds may not necessarily be accurate. Now, the tool that we are interested in is the geometry tab up here in the middle. Now, when you load this up, you'll see there's lots of options again available for calculating things, but what we want to do is come to the cube option, and this will ultimately give us the dimensions that we need for creating our Turner's cube. You can see an example up here in the right hand corner of obviously what one should look like, and then we've got the calculator going on here. Now, you'll see already obviously my measurements have already been put into this from when I was testing it earlier. So after completing the machining on my cube, it came down to 49mm. Now, the first thing I will point out, this is just a calculator. It doesn't matter whether you are using millimeters or inches. Put your measurements in and it will calculate them regardless. So mine was 49mm, so I've inserted 49, and we have an overlap set in here. Now what the overlap is about, if we look over to this cube in the corner, you'll see that where the corners touch, it is calculating that and working it out. Obviously, the smaller the overlap, the tinier the overlap will be between the corners of the cubes. You can go too far and ultimately make this very fine. I have done some testing and 6% seems ideal for me, but if you want to play it safe, maybe start at 10%. Now just as an example, I will adjust these numbers and you'll see all the calculations move down here. Again, with the overlap, it changes the depth of the cutting. Now what we need to note from these ultimately is both sets of numbers. We are going to be creating 4 circles cutting at different depths, and ultimately we just marry the numbers up. So the first circle we will create will be 44.4 millimeters in diameter with a cutting depth of 7.835. The next circle will be 32.34 and so on with a cutting depth of 12.38, and you'll do this for all 4 circles. Now to show you what I am talking about, I have mocked this up in a 3D model. If I just load this up now. And what we can see obviously is the cube we are working with, a 49mm cube, and the holes that we are going to cut. So as I mentioned, when in your CNC software, you will just design one circle straight away. And obviously mine had a measurement of 44.468. Obviously it rounded up to 44.7 in this scenario. And with a cutting depth of 7.84. And then you would do the second circle, the third circle, and the fourth circle, as we can all see mocked up here. Now I am doing this obviously in a 3D environment just to show you. You don't necessarily need 3D software to do this. It is purely for illustration purposes and also so we could actually test that everything was working. So once you've then created your 4 circles, ultimately it's about machining this 6 times on each side of the cube. Now if I move this screen over slightly, you'll see one that I mocked up earlier on. And ultimately we can see this is what we are aiming for. It is just those set of circles machined 6 times on each side. If I ungroup this, you'll start to see what I mean. So if I ungroup the shape, we can then see the top one there. And if I move that out of the way, you have an indication of what we have just created and the way it works. Now if I undo that and put it back in place, hopefully you can start to see it makes sense in terms of the grouping and the cutting. So whilst overall this looks very complex, it is essentially just machining 4 different circles on top of each other on all 6 sides of the cube. And if you are curious what this actually looks like within CNC software, then let me open up Carve CodeMaker. And as we can see, it is just 4 circles, as I've already explained, just with a different depth for each one. So the first one, 0 to 7 millimeters, number 2, 7 millimeters to 12 millimeters, number 3, 12 to 17, and so on. And when you actually simulate this in the cube or in the material itself, obviously it will just show as being done on one particular surface, and it's all about repeating that 6 times on each face of the cube. So let's jump over to the CNC machine and start this. Now we are sort of on the home straight now. We just have one more job to run. We've just got to run it 6 times obviously for each side of the cube. Now I can't stress enough at this point, make sure you are as accurate as possible for setting up this last part of the job. If you're struggling to find the center of your cube because of having a big bit, we'll swap over to something like a V-bit as I'm showing on screen now in order to find that center point, and then swap it back out for your aluminium cutting bit, as I say, just to guarantee you are dead center on this particular block. You will also notice I've got a clamp in place down in this bottom corner. The reason for this is to keep setting the X and Y on every time I change the cube. It means I can just take it out, flip it over, slot it back in, and once it hits that, I know it's going to be in the correct place. We did it earlier on with pencil, but for now we need to be as accurate as possible, and this is just going to work because it is a dead stop for every time the cube hits it. So all we can do now is let's get all of these circles cut in the first one and then flip it over and start doing the rest. So we've machined the top side now, we've just flipped this over and we're going to continue to machine the same in all 5 sides. So having now done 2 faces and starting to gain the breakthroughs in between the holes, I can see that one side of the connection is a little bit thin on the inner edge here. I'll put it on screen to highlight it. So something must be slightly off in my measurements, or the positioning of the cube itself maybe is a fraction off. But ultimately I'm going to carry on and continue to get the other 4 sides done. So it does take a little bit of work, but it really dials in your skills and you get a great piece at the end of it. Now, is this perfect? Not a chance. There are quite a few flaws and imperfections in this, all down to user error, some slight miscalculations, and it also did come loose in the vise at one point. So yeah, it is not perfect. I may even do a second one to try and improve it, but the bottom line is it's come out really nice, really shiny, and I'm happy with that for my first aluminium turner's cube. Now, I do hope you found the video useful. If you did, of course, please give it a thumbs up and make sure you've subscribed if you've not done so already. Thank you very much for watching the video, and final thanks as always goes to my patrons. If you want to get involved for one-to-one help, giveaways and early access to content, then check out the Patreon links in the description area below. I will see you all on the next episode.